All right, guys, welcome. This is the beginning of Unit 8 here, Arithmetic Sequences and Series. We're going to talk about this week, and then next week will be Geometric Sequences and Series. And my goal today with Arithmetic Sequences is, one, can you write an arithmetic sequence given the number of terms? Can you find, let's say, the 100th term of this? And then something about arithmetic means we'll be talking about, right? Biggest goal I want to get through is what you guys already know. Arithmetic is linear. So when you guys are taking the notes, arithmetic sequences are linear equations. All right. So matter of fact, here we go. I just want you to do this for a quick warm-up. You can pause the video and do this quick, but I want you to take the equation y equals 4x plus 5. One, I know it's linear because it's just x, right? 4 times x. It's not x to the third. X squared would be quadratic, all that kind of good stuff, right? So I want you to go through and fill in this chart, and then I want you to graph it. My sketch is going to be kind of weak, but that's all right. If I plug in 0, 0 times 4 plus 5 is 5, right? 1 times 4 is 4, plus 5 is 9. 2 times 4 is 8, plus 5 is 13. And as you guys start going along, I can just keep adding that plus 5, or sorry, that plus 4 each time we're going through. So this is going to be 17, and this is going to be 20, right? And then we would go to our graph. We would go to 0, 5, 1, 9, and we would figure out that it goes up linear, forming a straight line, okay? Wanted to show that because what we're going to see is this right here. We're going to be using T's and N's, so this is going to be term number, and then this is going to be the 0th term, which is not one that we're going to talk about, but we're going to be more worried about term 1. So 1, what's the first term? The first term is 9. Second term is 13. Third term is 17. Fourth term is 20. I want you guys to keep this in mind as we go through today, because some of it, one, it's going to be kind of a long video, I think, and two, we're building off things that we already know. So that's a good thing, okay? So a couple things that I'm going to highlight, and with notes, you can go back through and read all this. Common difference is basically like our slope. All right, so as we're going through, if you can find the slope of the line, you're finding out the common difference, how much we're going up or down by from one term to the next, to the next, to the next, to the next. Okay, is it arithmetic or not? Well, you got to take a look at that sequence, and are the numbers adding or subtracting by the same amount? In this case, we're all adding 3, so it's arithmetic. We're going to talk geometric next week. That's going to be something a little different. Recursive formula, I really don't like the recursive formula, because if I asked you to find the 100th term, you need to know the first term so you can find the second term, then you use the second term to find the third term. You keep going, starting at 1 and all the way to 100, right? The explicit formula, much nicer. If I wanted you to find the 100th term, you're going to have a bunch of information to plug in right here. You're going to plug in 100, and then you're going to do the math. Okay, so a couple things with this one. T1, first term or term 1. D is common difference. N is number of terms that we're trying to find out. Okay, so you might want to write that down, because that's going to be super easy. Oh, and then Tn is just the nth term. We're going to be using like T of 19, stuff like that as we go through. But T1 is the first term, common difference, and then number of terms. All right, so let's go and figure this stuff out together. All right. So first off, we have to see if it's arithmetic, geometric, it's not even arithmetic or geometric or not, as we just have to see if it's arithmetic or not. So we have to take a look from subtracting 4, subtracting 4, subtracting 4. Okay, so that is arithmetic. All right, we go down to number 2. That's 3. That's 5. That's 7. Though you could tell me the next term, right? It goes 3, 5, 7, then it's going to be adding 9, then 11. We see that pattern. However, it's not going up by a constant number, right? The number is always changing, so B is not arithmetic. A is, right? So now we have to identify the common difference. Done. Common difference is 4. Or sorry, negative 4. And then it says find the next 3 terms of the sequence. Well, then just go ahead and add negative 4. Keep adding negative 4. You can get negative 20, negative 24, negative 28. All right. So far, so good. Arithmetic is just adding that common difference every time. Again, linking it back to linear as much as we can. All right. So recursive formula. Not a big fan of this one because the way this is all set up. This Tn minus 1 kind of confuses people. That n minus 1 stands for previous term. So if I want to find, let's say, the 7th term, okay, how would I write that using this here? Well, if I want to find the 7th term, I need to know the previous term, which is the 6th term, and then I'm going to add 4 to it. And that's the pain in the butt, because I don't know the 6th term right now. All I know is they give me term 1. So arithmetic, kind of annoying. I get it. The symbols look weird. Again, just n minus 1 is the previous term. So if we're looking again for the 7th term, that previous term would be what is the 6th term. So we have to find out the first 4 terms of this. I'm just going to write it out the long way, again, to help explain a little bit. But the first term we know is 3. The second term, in order to find the second term, again, I'm going to go back up here. And I need to know the previous term, and then I have to add 4 to it. So the previous term is the first term, and then I'm going to add 3. If I want to find the third term, I have to know the previous term, so that's the second term, and I'm going to add, oh, sorry, not 3 to it, 4. Forget about that. And then again, if I want to find the fourth term, I need to know the third term, and I'm going to add 4 to it. So really, it's just taking and having to start at the beginning, going 3, and then second term, so first term plus 4 is 7, plus 4 is 11, plus 4 is 15. If we wanted to do the recursive formula and find the 100th term, the expectation would be going term 1, add 4 to get term 2, then add 4 to get term 3, then add 4 to get term 4, then add 4 to get term 5, all the way to 100. Super annoying long process, all right? That's how we would go through and do recursive, is always getting that previous term to help us out. All right, explicit gets us to the goal. So in this one, we're trying to find the 50th term. We're going to write an equation, and you're going to see when we're done with it, it's basically in slope-intercept form, all right? So we're going to take the explicit formula back from slide number 1, and then we're going to take our values and we're going to plug them in, of the ones that we know, and then we're going to use that to find the 50th term. So our formula is the first term plus, and we got to do n minus 1 times our common difference. So what I like to do is I just like to make some notes. What's the first term? What's n? And what's the common difference? And then that's going to help us build our equation. Right? Well, the first term is 2. The number of terms. We don't know the number of terms, so we're just going to leave it as n, because this is the formula for any amount of terms. And then the common difference is we are adding 4 each time. So we're going to build our equation. We're going to say t of n, which is the same thing as y, is equal to the first term 2 plus, and then we're going to do 4 minus 1, oops, n minus 1, I lied, times the common difference of 4. And then all we're going to do is we're going to distribute and collect our like terms and get it into one nice equation, right? So that's going to be 2 plus 4n minus 4, and then t of n is equal to 4n minus 2. All right, so that's slope-intercept form right there. This bad boy right here is slope-intercept form. Again, I wanted to link that back to what we were doing earlier with our graph. Way back here, okay? We just wrote something in slope-intercept form. Now, we just have to use this. If I wanted to find out what y was when x was 50, all we would have to do is plug in 50, do 50 times 4, and then add 5 to it. So same thing on the one that we're doing right now is I want to find the 50th term. I got me an equation. Now all I have to do is plug 50 in for n, which is the same thing as x. And then this time we're subtracting 2. 4 times 50 is 200. 200 minus 2 is 198. All right, so linear makes lots of sense. All right, that's saying the same thing. So the next thing we're going to do is we're going to take the formula they give us and find the first 4 terms. Well, that's nice. If they give us the explicit formula to find the first term, plug in 1. To find the second term, plug in 2. Find the third term, plug in 3. Find the fourth term, plug in 4. So it's a lot different than having to find out recursive formula is you had to know the first term, do something to find the second term, then use the second term to go to the third term to the fourth term. Here with the explicit formulas, we just have to plug in the term number we want to get to in for n, right? And then we just do our math and we get 25, 65, 105, and 145. Right? And if you take a look, again, slope-intercept form, 40 is the rate of change. And if you notice here, how much are these numbers going up by each time? They're going up by that slope value. Okay? Arithmetic means. What that's asking us to find out is basically we have a number 12. And then there's 3 arithmetic means. So basically, there are 3 blanks in our sequence. We have to fill in the blanks with the proper numbers. So what we need to do is we need to find the common difference, use that common difference and keep adding because this is actually getting bigger. We're starting at negative 12 and we're going to 16. So we're getting bigger. So we have to find out how much we're getting bigger by each time. So here is the process that we're going to do. I'm going to put it in layman's terms for us, and then we're going to go ahead and do it. So we're going to subtract the numbers given. Second thing is number of jumps, and that's just the basically how many times you're going to have to add this common difference or how many arithmetic means there are. Well, no, I don't want to say arithmetic means, but we're going to say how many times we have to add the common difference. Okay, step 3 is we're going to take part 1 answer and divide it by the part 2 answer. And then step 4 is we're going to use the common difference to fill in the blanks. All right, that's going to find us the common difference right here in step number 3. So if you want to pause the video, write this stuff down in your notes. We're going to subtract the numbers given. I'll show you how to find the number of jumps. Then we're going to take those 2 numbers from part 1 and part 2, divide them, and then use that to fill in the blanks. So we're going to take the numbers given. We're going to take 16 and minus 12. Or sorry, minus negative 12. And we get 28. Okay, now we're going to find the number of jumps. So if we started our sequence at negative 12, we're going to have to add the common difference once, twice, 3 times, 4 times. So that's kind of how I look at it as the number of jumps. We're thinking of going from negative 12 to 16. How many times do I got to make a jump? So that number was 4. 1, 2, 3, 4 jumps. So we're going to take 28. If we're going to divide it by 4, we get 7. We just found out our common difference was 7. So now I can go back up to our equation here, or sorry, our sequence, and now I'm going to add 7. Then I'm going to add 7. Then I'm going to add another 7. 2 plus 7 is 9. And then this is how you know if you get it right or wrong. You add that final 7. 9 plus 7 is going to equal whatever that last number in this is. In this case, it's 16. So we know we did it right. Okay, so again, we're going to subtract the numbers that they give us. We're going to divide it by the number of jumps. And then we're going to use that, because that's now our common difference, we're going to use that to fill in the rest of the blanks. All right, so now find the number of terms in the arithmetic sequence. Okay, so keywords to look for here, arithmetic sequence. I would always think explicit, so our explicit formula is this right here. The term we're trying to get to is equal to the first term plus the number of terms minus 1 times the common difference. Well, what do I know? We know the nth term, it's the last term, so the nth term is that negative 19, okay, because that's where the sequence stops. So I have that one. The first term of the sequence is 121, so I got that one. N, I don't know, because it's saying find the number of terms, right? So that's what we're trying to find out. And the common difference is 121 to 117 is going down by 4. So then you're going to take the values they give you, and then you're going to plug them in. So we got negative 19 is equal to the first term, 121, plus n minus 1 times the common difference of negative 4. So what we're going to do is we're going to take and subtract, divide, and then you get to add right at the end. Okay, so subtract the 121. Now, some of you might distribute the negative 4 and go ahead and solve that way. I could care less how you do it. I would just suggest dividing by the common difference. And then we're going to get 35 is equal to n minus 1. And then you add 1, n is equal to 36. So the answer of the question, how many terms are there of this sequence? There are 36 terms. All right, and again, what we did is we took the explicit formula for arithmetic. All right, we took that guy. We labeled everything that we knew. So we knew the last term was negative 19. The first term was 121. We were trying to find out the number of terms there were, and we had to figure out that the pattern was going down by 4 every time. We took those values, substituted them in, and then did our math. All right, we got one question left, and then you get to practice, and I'll give you the answers. All right. So after knee surgery, your trainer tells you to return to your jogging program slowly. He suggests jogging for 12 minutes each day for the first week. Each week thereafter, he suggests that you increase that time by 6 minutes per day. How many weeks will it be before you are up to jogging 60 minutes per day? All right. Well, it's linear. It's arithmetic, because we are going to be increasing by 6 minutes per day. All right, so let's think about this formula right here. This is going to help us out, because it's exactly what we just did. All right, we're trying to find out the number of weeks, so we're going to solve for n. What values do we know? Well, we know the last term. We want to get to 60 minutes jogging. We know we started out doing week 1 was 12 minutes of jogging, and then we are going to add n minus 1. Don't know n yet, and then our common difference is 6. So then subtract the 12. Divide by 6. and then add the 1, which is equal to 9. Right? Some of you, so we get the number of weeks is 9. Some of you might go like this. Keep that pattern going. Hey, you know what? Knock your socks off. The more numbers that we get, the harder it is going to be starting out small and keep adding that same 1 each and every time. Right? If you think about it, there was just 1 week at 12 minutes, right? So if you think about the math that we're doing, and it matches up exactly with the algebra steps that we did here. But if you're saying, hey, I want to get to 60 minutes. Well, the first week we ran 12, that's 48. And then the 48 minutes that we've increased since after week 1 was going up by 6, then we would take that and divide that by 6 and get 8. All right? That's 8 weeks of adding 6 minutes plus the 1 week where we had the 12 minutes, and that gets us our total of 9 weeks as well. Because it's linear, it works out nice. Okay? Go ahead, try 1, 2, and 3. Don't worry about number 2, the second part right here. Try it, but don't freak out about it. Think about the arithmetic means part the way we did it, just using the 10 and the negative 30. And then I'll show you exactly what we're going to do for our math. So go ahead, pause the video. You guys try out numbers 1, 2, and 3. And then I will give you the answers. All right, so write the explicit formula and the recursive. Explicit, we want to have the Tn is equal to the first term, 51, plus the number of terms, which we don't know, because it's the explicit formula, and we're just using this to find the nth term. And then we can see that the pattern's going down by -5. So that's the explicit formula to start out with, and then we're going to distribute and do all that work, and we get your final answer should be -5n plus 56. All right, so again, the first term is 51. If we were thinking of slope-intercept form, think of this as like the 0th term, because that's where our y-intercept is. That's where x is equal to 0. We want the x value to be 1 or 2, or the n value to be 1, 2, 3, 4. So if you're thinking and trying to connect it to linear, when we're in slope-intercept form, or we take that arithmetic sequence formula and distribute and simplify it down, that 56 is like the 0 term. Okay, recursive formula. Well, the recursive formula, we have to know what the first term is. That's 51. And then to find out the nth term, right, we don't know how far we're going yet. You would have to know the previous term. And then our pattern is going down by 5, so then it's going to be subtracting 5. All right, so let's set this up. We're going from 10 to -30. We'll spread that out a little bit. Well, how many geometric means are there? So this is the third term. This is the 8th term. So there's 4th term, 5th term, 6th term. I got to move this over a little bit. So really we're finding 5 geometric means. That didn't work out so well either. Okay, because 3rd to 4th, 4th to 5th, 5th to 6th, 6th to 7, 7 to 8. So there are 5 jumps, right? So this is where we're going to take -30, and we're going to subtract 10, and we're going to say, hey, there is a total of, we went from 10 to -30, we went down by 40 total, and that was over even increments. So take that and divide it by the number of jumps, which we said were 5, and we're going to get our common difference is -8. Then we're going to take that -8, and then we're going to fill in, that's going to be 2, -6, -14, -22, -22 plus -8 is -30. So we found out the right t value, or d value. that's one good way to check is if you're starting to add that D value in and you don't get to the last number, double check your math, make sure you're adding correctly. If that's still not right, then go back and you had set something up incorrect. Okay? Now, we want to use the formula to find the 15th term. Well, to find T15, you need to know the first term. We don't know the first term. We know the third term, and we know our pattern is going down by 8. So I'm going to go up by 8 2 times to get to the first term. So the first term is going to be 26 plus, we want to find the 15th term, so 15 minus 1 times our common difference of negative 8. You type that into the calculator and you get negative 86. Now there are more than one way, or more than one ways, I guess, to find out negative 86 from where we were at, right? If you found out the common difference is negative 8, you could take the 8th term and keep subtracting negative 8, doing recursive formula style, doing subtract 8 or add negative 8 to get the 9th term, then to add negative 8 to get the 10th term, to the 11th, to the 12th. You can do it recursively or you could do it explicitly. Okay. Edgar is getting better at math. His first test score is 50. Then it's 53, then 56, then 59. If he takes 20 tests throughout the year, what will his score on the final exam be? Well, the pattern is arithmetic because we are adding 3 each time. So if we want to find out the 20th test score, we need to know the first term, which is 50. 20 tests times the common difference of 3. So we got 50 as the first term, plus 20 minus 1, or just plus 19 times 3 is 107. He will get 107 on his final exam. That's not percent, that's just saying the score he got through. All right, so that's arithmetic. It's all linear. Have a great day. Your work is in there. Submit it. It'll get graded. Be ready for arithmetic series tomorrow. Have a good day.